Hello, good evening, everyone. Am I audible, right? Let me know through the chat box quickly. Yadgiri, guys, how are you? Yes, guys, if I'm an audible means please do note down in a chat box quickly. Am I audible, right? No need to waste the time today. And by the way, I think this is the first time Yadgiri, you people log in here for a live class, right? If it is convenient to text means do drop your message in our chat box. Okay, if it is convenient, meanwhile, okay, or else no worries. And by the way, this is Shan. I'm working in a Harvard school as a program associate for the physics. Within 2 minutes, we'll start the session, guys. Okay, just 2 minutes. Yes, good evening, guys. Yeah, I your messages are reaching me. Okay, we'll start our today's class. Okay, no need to waste the time further. Yes, up to yesterday we talk about the wave optics and as well as the ray optics. Correct now. In ray optics and wave optics, as per your board examination and as well as the competitive examination wise, that these two are very good weightage chapters. Okay, no need to neglect it, as possible as try to solve more and more problems there. Okay, and from this chapter dual nature of matter and radiation is there. No, this is also one of the chapter you already completed in 11th standard of chemistry. Correct now, in chemistry I already completed this one, but here the things which are going in a different way. Okay, no worries. From this chapter, definitely one question will be come for the JEE exam. JEE के लिए one question. Okay. For NEET, I don't know. I can't able to expect exact numbers. Actually, previous year में NEET questions here, there were at least 2 questions they came. Okay, might be we can take around 2 questions from NEET. Correct now. And then after, from today onwards, I'm going to deal the chapters little faster, just because of we got to know one point, that is we need to help for you for in the case of pre-board and as well as the board examination. Right now, in that sense, we are going little fast. Okay, if you are getting any doubt between the session, please drop your doubts in a chat box. Okay, right? Hi Shilpa. Okay, in dual nature of matter and radiation, especially in this chapter, today I'm going to dealing the concepts of work function, electron emission, photoelectric effect क्या होता है, and few important graphs which are coming under the photoelectric effect. Cool. These are other topics which I'm going to cover in this today class. Right? Okay, let's get into the chapter. First introduction part. Up to now, guys, you know wave optics. Correct ना? Wave optics ने आप पढ़ा है Young's double slit experiment. Correct ना? Young's double slit experiment पढ़ा था. उसके बाद diffraction of light. Diffraction of light. And next thing, you know, in a electromagnetic waves, de Broglie's wave. Correct ना? De Broglie came there. Okay, these are the 3 scientists. Actually, they are dealing the light wave, light को they मानते था as an wave. Okay, they're considering the light as a wave, and they successfully explain the concepts of interference, diffraction, and extra. Okay, reflection, diffraction, everything. But coming to the part of, actually in this chapter, we are going to learn about the dual nature of matter, में especially photoelectric effect. Yeah, photoelectric effect. Okay, these are one of the new concepts which we are going to learn in this topic. This photoelectric effect cannot able to explain through this wave nature of the light. That's why here again 3 new scientists came. Okay, पहला साइंटिस्ट तो हमारा न्यूटन बाबा. कौन? न्यूटन. ओके, न्यूटन आ गया. सेकेंड प्लैंक्स आ गया. थर्ड वन कमिंग टू दी आइंस्टाइन. क्या हो रहा है इधर? आइंस्टाइन. राइट, Einstein. Okay, these 3 scientists, they're saying that they are for exactly explain the photoelectric effect with the help of light, but these 3 people actually consider light as an particle in nature. Particle in nature. Okay, that's why here we are studying that light has an dual characteristics. Right? That's why we call this chapter as an dual nature of matter and as well as radiation. Okay, na? Right? Especially this is exactly explained by the de Broglie. Whom? De Broglie. Okay, de Broglie एक scientist है. He completely explained about the particle nature of a matter. How he explained? I will give an example before going to that exact chapters. Take an example first. Okay, he given an equation that lambda value will be equal to h by p. This is a great equation. Actually, it is given by the de Broglie. Actually, क्या है ना? Just imagine this is a matter. This is matter. Matter means उसके पास mass होता है ना, m. Right? मान लो ये matter move हो रहा है with the action of force. Means while it is moving, it has a velocity. Means when it is moving in this direction, it has a velocity also. What de Broglie says, no, a matter when it is moving, no, along with this matter, there is a wave is associated. Actually, it says that a wave which is associated with the matter, moving matter. Are you getting my point? Actually, suppose manlo this is me, right now. I'm moving means along with me there is a wave. ऐसे कैसे होता है sir? When you just you might be asked like this. If we are walking means okay, we can able to identify the person only. We can't able to identify the wave, correct now? Why it is happening? देखो इधर ये given on equation h by p no, इधर h मान इसका कांस्टेंट वैल्यू है 6.64 into 10 to the power of minus 34 joule second divided by p means it is nothing but momentum. p है momentum, mass into velocity होता है, करेक्ट ना? इधर अगेन 6.6 into 10 to the power of minus 34 divided by mass. मान लो if I am moving means मेरा mass होता है around 60 kg. Okay, if I'm moving with a velocity, maximum velocity means around 10 meter per second, correct है ना? 10 meter per second. इसके ज़्यादा भाग दे, if more than this velocity, if I am going to moving means, or if I am going to running means, I can win the 100-meter medal, correct ना? Because हुसैन बोल्ट का रिकॉर्ड है ना, उसको तोड़ सकता है हम, correct? That's why I'm taking only 10 meter per second. Okay. Okay, after calculating this one, guys, you will get around 8.25 into 10 to the power of minus 37 मिलता है. Lambda value means meter. Lambda is nothing but wavelength. Okay, ये wavelength क्या है सर? देखो इधर ये wave है ना, ये wave में एक crest से crest तक होता है ना distance. We call this as an wave. Now, know here, just get inside the concept properly. इधर 8.25 into 10 to the power of minus कितना है? 37 है. Means minus 37. We can't able to measure this much small quantity. Correct now? That's why when you are moving with some velocity, there is a wave is always associated with you, right? But we can't able to see it because its distance or wavelength is very small. Wavelength क्या होता है? Very small. Actually, this is experimentally also proved. Okay, that's why here it correctly explain what is, you know, de Broglie. Actually, wave is not means light is not an wave and not an particle. Light has a dual characteristics. This is a statement which is given by the de Broglie. Guys, one more point I want to put here. This is a chapter like more theory part. Okay, don't try to concentrate more here. Okay, and if you are getting any doubt means meanwhile please drop your doubts in a chat box. Cool. Okay, then fine, we'll move to the next point. Just a minute, I will put this one. Yes, well, my screen is visible right properly? No worries, we'll learn this all the things in a chapter only, just for the sake of know about the chapter. No, that's why I introduced the chapter by the de Broglie wavelength. Cool. Come to the point. This chapter में very important thing is that work function. Before that, free electron in a metal. Free electron क्या होता है? आपको पता है? ये atom है ना? Just imagine this is an atom. ओके, आटम है. आटम के अंदर क्या क्या होता है? आटम के अंदर क्या क्या होता है? आटम इज मेड अप ऑफ, सर हाउ डू यू नो सर? आटम इज नेक्स्ट इन द नेक्स्ट चैप्टर. नो, राइट? डोंट आस्क क्वेश्चन लाइक दैट. जस्ट इमेजिन दिस इज द आटम. इनसाइड द आटम सेंटर पार्ट वी विल कॉल दिस वन एज एन न्यूक्लियस. न्यूक्लियस में क्या क्या होता है? प्रोटॉन एंड एज वेल एज न्यूट्रॉन, करेक्ट ना? अराउंड द न्यूक्लियस electrons which are actually revolving, correct now, in different orbits. Here free electron means there are, we generally we know field. Okay, KLMN, 4 shells are there. Just imagine like that. Okay, KLMN, 4 shells are there. Okay, in outermost shell mein Okay, whatever the electrons are present, if it is not completely filled, means we call this one as an vacant electrons or valency electrons. Correct now? These electrons we called as an free electron. Means electrons present in a outermost shell. Outermost shell. They are like a mad dogs, right? Actually, they are not yet binded properly to the nucleus. Okay, they bonded with a small amount of energy. Manlo, this is nucleus, means this is the outermost electron present here, right? The energy between a outermost electron to the nucleus is there, no? The energy, okay, it's very less amount. It's very less amount, right? If you are giving some amount of energy to this one, no, it will come out from the outermost electron. This is the property of the valence electron. Clear? Am I clear? Yes. Good. Okay, coming to the point next. ये work function क्या होता है इधर? कौन सी work function है? Work function. Marriage function नहीं? Right? Okay. इधर work function को जानना बहुत ही important है ये chapter में. Already I told you guys. This is a metal plate. Just imagine one metal plate is there. Metal plate के ऊपर surface में free electrons आते हैं. क्या है? Free electrons आते हैं. Na plenty number of free electrons. Okay. All these are bind with some energy to the nucleus. Correct ना? Atom होता है. Atom के साथ bind होता है energy. Correct ना? Here they binded with some energy, no, to the metal surface. That energy is called the work function. Work function क्या है? I hope you got an idea about it. Work function is nothing but energy only. Energy only. कौन सी energy? Actually electron bond with nucleus. Correct now? That amount of energy we called as an work function. We are going to call this work function as an phi. Okay, just imagine guys how means if you people are settled down in a classroom. Now you are in a classroom. You people are present on a bench. Just imagine bench is a metal. This metal is a bench for all of you. Okay, you are all electrons. You are all electrons. Okay, you are all bind with some energy to the bench. To remove you people from the bench means I need to put an extra amount, right? Correct now? Here, how much amount of energy you people are stick together in a bench? No, that is called the work function. I hope you getting my point. Okay, we are going to mention this one as an final. Work function is nothing but simple sa hai. The amount of energy, in that energy the electron already bond with the atom. Clear? Okay. Next, अब electrons है. Okay, if electron is there means actually it is bond with the energy. That energy we called work function. Phi naught we are going to call that one. Phi naught. Okay. Actually, you guys know that energy means E is equal to h nu. Don't forget this one. It is already introduced in chemistry. Correct na? Simple sa. Okay. Then phi naught ko we can write as an h nu naught. Okay, this is also energy, no worries. Okay, don't be confused with that. This is also energy, h nu naught. In nu naught क्या है? Work function का frequency होता है. Work function का frequency होता है. Now observe here. Here some wave like it is coming. No, this is a kind of energy. I don't want to mention which kind of energy. Okay, energy तो h nu होता है. Okay, this much amount of the amount of energy which is coming here, if it is incident on this electron, no, electron क्या करता है? Energy को observe करता है. After observing the energy क्या होता है? It will be jump out from the nucleus. Means not nucleus, outermost electron shell. Are you getting my point? When they got energy, sufficient energy, they will come out from the orbit. Okay, we call this process as an photoelectric, sorry, electron emission. Sorry, in advance I told you. Okay, it's a kind of electron emission process. Clear enough? राइट, आई होप इट इज क्लियर। वर्क फंक्शन क्या होता है, वर्क फंक्शन के ऊपर इलेक्ट्रॉन बाइंडिंग एनर्जी में होता है, राइट। इफ यू गिव अस सम amount of energy which is actually equal to or greater than this much energy, when the electron will be come out from the metal, this process is called electron emission. No worries, if you understood this much means it is enough. And guys, I want to add two more points here. We know Vibgyor, right? VIBGYOR, correct now? 7 colors are there. They are actually arranged in the form of increasing order of wavelength. Means Vibgyor means violet से red color तक lambda क्या होता है, increase होता है, right? Same thing, violet से red color के तरफ जाने से frequency क्या होता है, decrease होता है. Frequency will be decreases from violet to red, and violet to red if you are going means lambda will be increases. Don't forget these things, these are very important. Why means here frequency means it is nothing but energy. I am saying means देखो इधर carefully, E is equal to h nu is there, correct ना? H is an Planck's constant, it's a constant value, h value. If you, we can write this one as an energy is directly proportional to the frequency. Energy is directly proportional to the frequency, correct ना? Means meanwhile here I'm telling you guys, from Vibgyor में violet to red color if you're moving in this way means frequency decreases, no? Similarly energy also decreases because energy is directly proportional to the frequency of the light, right? What I'm saying, I hope you guys are understanding, correct ना? इधर violet color के लिए I will write in the next page. Okay, देखो ध्यान से देखो, okay, correct now? Violet color having less wavelength, correct, but it has a frequency high. It's a yes, okay, high, correct now? If frequency high means energy also high. One thing is completed, violet color का हो गया, correct now? Next coming to that red color. red color इधर है, okay. red color के लिए lambda क्या होता है, more means ज्यादा होता है, correct ना? Coming to the frequency, frequency is less. If frequency is less means energy of the color red color will be less. Clear enough? 3 points. If you know this means it is enough for this chapter, right? Is it clear? Simple सा equation है, E is equal to h nu. From this equation only we derive this outcomes. Cool. Let me know through the chat box if it is understood means yes, right. What I will expect, no, that much I can't able to complete in online class. I don't know why. Okay, leave it. Coming to the next point again, work function means it's already energy which is already bonded with the electron. Electron को bond करता है ना, वो energy को क्या कहते हैं हम, work function. We call that one as an h nu naught. Okay, here you need to know about the relation between nu and as well as wavelength. That is nu is equal to c by lambda होता है. If you substitute here means work function क्या आता है, work function will be h nu means, just a minute, nu means c by lambda naught. What we'll call this one as c by lambda naught, correct now? Why I'm mentioning lambda naught I will tell you later. Okay, here this nu naught we will call this one as an threshold frequency. Threshold frequency, note down this one. And lambda naught we call threshold wavelength. We call this one as an threshold wavelength. ये threshold wavelength क्या है, I will tell you. Listen, just मान लो ये मेटल सरफेस है ना, इस ये मेटल सरफेस के ऊपर फ्री इलेक्ट्रॉन है, और फ्री इलेक्ट्रॉन विच इज बॉन्डेड विद द एटम और न्यूक्लियस with 3 electron volt energy. Okay, this is what the energy of means. Consider this is a work function energy. Okay, if you give the 3 electron volt amount of energy to the electron, then only it will come out from the metal surface. It will come out from the metal surface when you will give 3 electron volt amount of energy, or else it won't come. Correct now? That particular frequency is there, no, इसके साथ energy के साथ, we call that one as an threshold frequency. Correct ना? Frequency है means उसके साथ साथ क्या होता है, wavelength भी होता है. Correct ना? That's why we call corresponding wavelength as an threshold wavelength. Clear है? Clear है ना? Okay, good. Next thing is that yes, metal के लिए, okay, just I told you that this is one metal. जनरली मान लो इसको इलेक्ट्रॉन कितना है, वर्क फंक्शन 3 इलेक्ट्रॉन होगा. ओके, जनरली ये मेटल, आई एम गोइंग टू कॉल दिस वन एज एन मेटल ये. ओके, इसका वर्क फंक्शन है 3 इलेक्ट्रॉन वोल्ट, 3 इलेक्ट्रॉन वोल्ट, राइट. दिस 3 इलेक्ट्रॉन वोल्ट इज कांस्टेंट फॉर दिस होल मेटल. Wherever the electrons are there, no, here electron is there, here electron is there, here electron is there, here electron. For all these electron, this work function energy will be same. It is constant for a single metal. Okay, if I'm going to change another metal, metal B metal, okay, वो मेटल में होता है ना फ्री इलेक्ट्रॉन्स, एक्चुअली दे बॉन्डेड विद मोर देन दिस इलेक्ट्रॉन एनर्जी, मींस जस्ट थिंक कर लो 6 इलेक्ट्रॉन होगा. करेक्ट ना? देन इसका थ्रेशोल्ड फ्रीक्वेंसी भी चेंज होता है, थ्रेशोल्ड वेवलेंथ भी चेंज होता है. करेक्ट? दिस इज कॉल्ड द वर्क फंक्शन. मींस फॉर a given metal the work function phi value will be constant. For different metal के लिए वर्क फंक्शन क्या होता है, डिफरेंट होता है. करेक्ट ना? जस्ट मान लो गाइस, बेस्ट एग्जांपल आई विल गिव यू नाउ. जस्ट इमेजिन दिस इज अ बेंच, एक्चुअली यू पीपल आर सिटिंग हियर, दिस इज यू. करेक्ट ना? दिस इज योर फ्रेंड, ओके. जस्ट इमेजिन दो अलग अलग बेंच में बैठा है. ओके, इसको उठाने के लिए आपको more force required is more compared to this one A and B. Correct ना? Like that different metal में different energy होता है. Clear ना? Clear? बेगा हेली chat box में. If you are actively participating now, then it will boost my energy. That's why. Yes. Okay, cool. Next thing is that here electron emission होता है. I told you that. ये मेटल पे क्या है, वर्क फंक्शन है. मान लो ये वर्क फंक्शन h nu है ना, h nu नॉट 3 इलेक्ट्रॉन वोल्ट है, राइट. ये 3 इलेक्ट्रॉन वोल्ट सप्लाई करके हम क्या करते हैं, इलेक्ट्रॉन को एजेक्ट करते हैं मेटल सरफेस. दिस इज अ process we call that one as an electron emission. Correct now? The electron emission will be taking place according to me in our books. Okay, 3 kinds of electron emission they suggested here. First one is thermionic emission, second one photoelectric emission, third one field emission. क्या होता है thermionic emission? Thermoionic, the name it is actually it is suggesting that thermo means you got to know that it's an heat. Okay, you need to supply heat for this metal, okay, to eject the electron from the surface. Okay, कितना हीट सप्लाई करना है, एक थ्रेशोल्ड फ्रीक्वेंसी को इक्वल होना है. Okay, उतना अमाउंट ऑफ heat if you want to supply means electrons start to eject from the metal surface. Okay, this process we call, means here the process of electron ejection takes place just due to the supply of heat. That's why we call this one as an thermionic emission. Clear है ना? right? Okay. Next thing is photoelectric effect. Photoelectric effect is nothing but, guys, don't miss. क्या बोलते हैं इसको? Don't get confused with this symbol. Okay. Actually, I copied the all the figures here. Okay. When you need to supply the heat only here, main function. Second function is photoelectric effect. Means you need to insert or you need to eliminate suitable amount of light energy. ओके, लाइट को इंसिडेंट करने की वजह से फोटोन को मींस इलेक्ट्रॉन्स को एजेक्ट कर सकते हैं मेटल सरफेस पे. ओके, दैट काइंड ऑफ फोटो इलेक्ट्रॉन एमिशन वी कॉल्ड, sorry, electron emission we called photoelectric emission. Why? Sorry, how? You know, right? Already I told you that with Gaya, among this seven color, guys, this is a question. Listen, among this seven color, which color having high energy? High energy किसको है? बोल दो. High energy, yes, absolutely. High energy है violet color की. Just because इसका frequency ज्यादा है, hence energy also more. That's it. Clear है ना? By look here, energy is more for this one. Second, indigo blue, red. Means red को क्या होता है? Energy बहुत कम होता है. Correct ना? By changing color here, we can क्या करते हैं? फोटो इलेक्ट्रिक एमिशन को कर सकते हैं. करेक्ट ना? suitable amount of energy which is required for the given metal. Actually, it is depending upon the work function. Correct ना? This is photoelectric. Coming to the next point, field emission. ये क्या है field emission? Field emission करने के लिए क्या करना है? फुटबॉल फील्ड को लेकर जाना है ना मेटल को, और वॉलीबॉल कोर्ट को, और क्रिकेट फील्ड. Where we need to take this metal plate? No. Field emission is nothing but, guys, electric field को supply करना है. कैसे? Either positive, negative. Charges, if you want to supply, means you know in a capacitor, plates के बीच में electric field होता है. Positive and negative charges will be accumulate on the plates. Means इन दोनों का बीच में क्या होता है? Electric field will be developed like this. Right? This is the electric field which is developed between two charges. When electric field will be developed between two charges, actually metal surface में कौन होता है? Electron होता है. Electron का एक property है, it is always moving opposite direction to the applied electric field. Correct ना? Electric field का direction इधर है, electron किधर move करता है? Opposite direction में. You know in a current electricity, drift velocity कैसे होता है? Same condition, no? This is a kind of emission. By applying the electric field, we can eject the electron from the metal surface. These are the types of electron emission. Okay, majorly in this chapter we are going to deal with photoelectric emission. Clear? कैसा लग रहा है क्लास? एक फील ಮಾಡ್ತಾ ಇದೀರಾ ಕ್ಲಾಸ್ ನ? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಲ್ಲ? Cool. We'll move to the next one. Photoelectric emission. Before that, yes. Hey, thank you, Jai Kannada. Okay, next thing is that actually photoelectric effect, which is observed by first two members. We call that one, the name of the two persons are Hallward, okay, and Linard. These are the two persons actually first find out the photoelectric effect. How they are conducted? No, they took zinc plate first. ये क्या है? Zinc plate. Okay, this zinc plate basically it is negatively charged one. Okay, basically it is negatively charged zinc plate. Correct na? Now what they did actually they introduced or eliminated this zinc plate with some amount of energy, light energy. E means एच न्यू होता है ना यार, ये मान लो ये वायलेट कलर है, कौन सी कलर, ओके वायलेट कलर है, वायलेट कलर को इंसिडेंट कर दिया बिकॉज वायलेट कलर हैज एन मैक्सिमम अमाउंट ऑफ एनर्जी, करेक्ट ना, दैट्स व्हाई मान लो for our shake from this point onwards we're going to take this one 6 electron volt. Throughout the chapter I'm going to consider 6 electron volt only for a violet. Okay, I'm taking example, that's it. Okay, 6 electron volt incident किया इसके ऊपर. Okay, these are all the electrons. Okay, actually this metal plate को चाहिए था work function energy around 2 electron volt. कितना चाहिए था, only 2 electron volt. क्या हो गया इधर, due to this amount of energy what Halwach and Leonard supplied, okay, these electrons absorb that energy and they start to eject from the metal plate, correct now, all the electrons are come out, right. After then they check this zinc plate, okay, now the zinc plate is completely neutralized. क्या हो गया था, न्यूट्रलाइज्ड हो गया था. दिस इज द फर्स्ट एक्सपेरिमेंटल ऑब्जर्वेशन डन बाय द हलवाच एंड एज वेल एज द लेनर. ओके, नाउ इट इज कंप्लीटली न्यूट्रलाइज्ड. नेक्स्ट क्या करता है ना, ये न्यूट्रलाइज्ड जिंक प्लेट के ऊपर अगेन दे इल्यूमिनेटेड सम अमाउंट ऑफ एनर्जी दैट इज H is equal to H nu. अगेन दे सप्लाइड अमाउंट ऑफ एनर्जी. नाउ क्या होता है एक्चुअली, सरफेस इलेक्ट्रॉन तो बाहर आ गया और भी इलेक्ट्रॉन पॉजिटिव बोथ आर नाउ दे आर इक्वल नो हियर. इलेक्ट्रॉन कितना होता है उतना पॉजिट्रॉन होता है व्हेन द बॉडी इज न्यूट्रल, राइट, व्हाट आई एम सेइंग. नाउ देखो, when again they illuminate the electron suitable amount of frequency, again these electrons are there, no, started to move out, right. Then the zinc plate का हालत क्या हो गया, इधर जस्ट it will become positively charged plate, correct ना. This is the first experimental observation which is done by Halwach and as well as Lina. Now it is positively charged one. Okay, I told you that guys, I introduced here only 6 electron volt. कितना इंट्रोड्यूस किया था मैंने, 6 इलेक्ट्रॉन वोल्ट का एनर्जी सप्लाई किया था मैंने. ओके, मेटल प्लेट को वर्क फंक्शन कितना था एक्चुअली, हियर बोल दिया मैंने 2 इलेक्ट्रॉन वोल्ट. ओ गॉड, 6 इलेक्ट्रॉन वोल्ट में 2 इलेक्ट्रॉन वोल्ट इजेक्ट होने के लिए यूटिलाइज हो गया. व्हाट अबाउट द रिमेनिंग 4 इलेक्ट्रॉन वोल्ट, कैन एनीबॉडी टेल मी व्हाट विल बी हैपन, what happens to this 4 electron volt remaining? Yes, right guys, all right what you said. Okay, remaining energy क्या हो गया ना, actually I told you that electron come out from the metal surface means it is required the energy, it is work function, it will be come out, that's it. If it is want to move further distance means it needs some amount of energy, correct na? That energy is converted as an kinetic energy by using this remaining energy. Okay, remaining energy क्या होता है ना, उसमें क्या होता है, kinetic energy के तरफ change होता है. How, actually you know that, right, conservation of energy, correct na. According to the conservation of energy guys, whatever the energy if you are going to supply to any metal or anything, okay, in our nature, it should be transferred to the another form. It will not destroyed, right, and we can't able to create extra also. That's the conservation of energy statement, hai na. We can't able to create the energy neither be created nor be destroyed, but it will be transferred from one form to another form. Same thing here it is happened. I introduced 6 electron volt, okay, 2 electron volt utilize हो गया, electron to come out from the metal surface. Okay, remaining 4 electron volt क्या हो गया, it is provided as an kinetic energy for the electron to move further away from the metal surface. Cool, right? Yes, we'll move to the next one. Next topic is that exactly photoelectric effect is a second observation which is made by the same Halwach and as well as Lina. क्या कर दिया ना इधर they took one vacuum tube. Here what you are going to observe the green color है ना एक इसको कहते हैं हम vacuum tube. Okay, this is a vacuum tube. This is a light. It's a yellow light, right? Okay, now we are going to take this one as an yellow color light. Okay, blue से sorry violet से yellow change हो गया. Okay, and then inside this vacuum tube nothing is there. We introduced two plates here. Just look at here. There are two plates are there. Okay, just a second. Yes. These are the two plates which are introduced inside this vacuum tube, guys. Okay, we call this first tube, sorry, metal as an cathode. Cathode is nothing but, guys, photosensitive metal. Up to now, what are the metals we took now here? देखो इधर ये प्रोसेस के लिए लिया था ना हम metal. The metal we will call this one as an photosensitive metal. इसको हम कहते हैं photosensitive metal. By utilizing the energy, electron क्या करता है? They will come out from the metal. No, we call this electrons as an photoelectrons. Right? Okay. देखो इधर. First one we called cathode. Right? Why? Okay. Cathode. Second one इधर है ना right side में. इसको हम कहते हैं anode. Right? Cathode it is always negatively charged one, means इसके ऊपर क्या होता है negative charges electrons होता है. Anode means it is positively charged plate. करेक्ट है ना. देखो क्या करता है मैंने एक कैथोड को लेकर मैंने इधर एक गैल्वेनोमीटर है उसको कनेक्ट करता है मैंने and this galvanometer I'm going to connect another end with the anode. Okay, now it is a complete circuit. देखो observe करो carefully. This is a light yellow color one. Few things I want to say again. This is a yellow color light. करेक्ट ना. इसके पास wavelength भी होता है, frequency भी होता है and energy भी होता है. Frequency is nothing but once again I'm telling that energy of the light. Are you understanding my point? Okay, now just look at here. When this is a yellow light with 100-watt bulb, imagine that it is a 100-watt bulb. Okay, when you switch it on this one, no, इधर एक window होता है, इधर एक window. Okay, through this window these light rays which are start to fall on this cathode metal plate. Start to fall on the cathode metal plate. मान लो cathode metal plate है ना, इसको हम कहते हैं emitter. Why we are saying emitter means electron will be emit from the plate. No, that's why इसको एक work function होता है 5 value. मान लो उसको 3 electron volt. कितना? 3 electron volt means this amount of energy you are going to supply means then after the electrons start to eject from the metal surface or else they won't. Okay, now imagine this is a yellow light means it has a particular frequency, particular wavelength, particular energy. करेक्ट ना. मान लो एनर्जी है 10 इलेक्ट्रॉन वोल्ट. मैंने चेंज किया स्लाइड टू स्लाइड. लास्ट आई टोल्ड यू दैट 6 इलेक्ट्रॉन वोल्ट आई विल टेक. नाउ आई एम टेकिंग 10 इलेक्ट्रॉन वोल्ट. कोई प्रॉब्लम नहीं. करेक्ट ना. 10 इलेक्ट्रॉन वोल्ट है एनर्जी. ओके, क्या है एनर्जी? फिक्स्ड फ्रीक्वेंसी, फिक्स्ड वेवलेंथ. दिस आर नॉट विल नॉट चेंज. करेक्ट ना. And one thing I want to know about from your side, what is mean by intensity? Intensity क्या होता है guys? Intensity electronicity नहीं है, intensity. If you know means please know. If you know means please drop your answer in the chat box. इंटेंसिटी क्या होता है? सिंपल है. Okay, don't mug up this one. Intensity is nothing but brightness. Brightness. ಯಾವ್ದಾದ್ರು ಒಂದು ಬಲ್ಬ್ ಅಲ್ಲಿ ಎಷ್ಟು ಬೆಳಕು ಬರ್ತಾ ಇರುತ್ತೋ ಆಚೆ ಅದೇ ಇಂಟೆನ್ಸಿಟಿ. ದಟ್ಸ್ ಇಟ್. ಸಿಂಪಲ್ ಏನಾ? ಫ್ರೀಕ್ವೆನ್ಸಿ is nothing but energy. Intensity is nothing but brightness. Keep this one in your mind. Okay, coming to the point. Sorry, 3 electron volt which is needed for this metal plate to eject the electron. हम कितना दे रहा है? 10 electron volt. Okay, कितना? 10 electron volt. Correct ना? Okay, these electrons from the metal surface absorbs the energy which are coming there and they eject from the metal. Correct ना? इधर 3 electron volt चाहिए था, 3 electron volt को utilize कर दिया. remaining 7 electron volt है ना? This 7 electron volt utilized as an kinetic energy for all these electrons. Correct? As you already told you that kinetic energy तरह utilize होता है. Okay, I need to know one more point here. Just मान लो I supplied here 100 watt. Correct ना? 100 watt intensity वाला light. Okay, 100 electrons are emitted. कितना? 100 electrons. Now let me know guys, is this 100 electrons also reach this positive plate? Is the 100 electrons will be going to reach there? Will it be? No. 100 electron will not reach this positively charged metal plate. Actually, electrons negative, that has to come near the positive plate. Yes, I will agree that one. But here 100 electron will not reach because when they are ejected suddenly, no, at that time there is an might be takes place of collision. Due to collision, क्या होता है? They will be move away also. That's why if 100 electron eject means around 50% will be come near the positive metal. Maybe 50% of that. Clear है ना ये बात? Now देखो carefully. These electrons start to move from negative plate to positive plate means here in this galvanometer it start to deflect. It start to dance. Why? Yes, because in this circuit there is an current developed. Why current developed? Actually moving electron creates current. No, that's why. Right? Current क्या हो गया? Develop हो गया. Okay, this process we call as an photoelectric effect. Clear now? क्या करना है? With a suitable amount of energy, when we are going to incident on a metal plate, electrons are start to eject from the metal plate and they constitute the photocurrent. Correct now? This process, whole process we called as an photoelectric effect. Clear enough? Let me know. Is it clear? Is it clear? Let me know. Simple, sir. If you have any doubt means please drop your doubt. Okay, you have any doubt about it means please drop your doubt. Okay, it's cool. Next क्या है ना? Next क्या है ना? This is all about first scenario. Second scenario is that guys, I want to increase the intensity. Right? Intensity increase करना है मुझे. Okay. How to increase the intensity? Let me know. Is there a chance of increasing intensity without changing the light? Okay, I'm telling that yellow color here light. Okay, light cone means color of light I'm not going to change, but I need to change the intensity. Brightness को क्या करना है? Change करना है. How to change the brightness? Simple सा एक तरीका है. Just move this light source near the metal plate. Brightness ज्यादा होता है, intensity ज्यादा होता है. Or else move that light source away from the metal plate. Intensity कम होता है, brightness भी कम होता है. This is the first thing. क्या करना है first thing में? सोर्स मूव करना है, करेक्ट ना? If you move near means intensity will be ज़्यादा, if you move away from means intensity will be low. Just मान लो यार, in front of you there is a bulb means, okay, you will face like that, there is a bright light is coming to your end, correct ना? Right? If it is moving away from you means you feel like a relaxed one, just because of intensity decrease हो गया, correct ना? Okay, cool. Now tell me one more point. When if you move this bulb near this side, no, intensity क्या हो गया, increase हो गया. If intensity will be increases means the ejection of electron will be increases. Let me know. Yes, of course. If intensity increases means photoelectrons which are ejecting from the surface, no, they are also more. Okay, if the number of electrons will be start to eject more means the photo current which is taking place, no, that is also more. Clear? ये पहला point, first and second observation. Okay, let us check another one point, simple experimental evidence I'm going to tell you here. ये क्या है ना, up to now I didn't introduce any battery and anything. Okay, same source, the light source. Okay, same connection. Here I introduced one. क्या हो गया इधर? Okay, it is not required. In a simple way I will explain you. In a simple way I will explain you. Yes, here it is. Okay. Same thing. This is a vacuum tube. This is the metal plate. Two metal plates. This is cathode. This is anode. Now I'm going to connect these two with a battery. Now I'm going to connect these two with the battery, negative, positive. Okay, same thing. And then here is the light. Which light this is? Don't say orange light. This is a yellow color light. कौन सा? Yellow. Already I told you इसका frequency है, wavelength भी है, इसका एक separate energy भी है, 10 electron volt I took here. Correct now? When light is illuminated on this metal plate, okay, electrons start to move towards the positively charged plate. Correct now? मान लो previously actually, okay, at that moment only electric current is not known. Okay, before connecting this potential, इस बैटरी कनेक्ट करने के पहले क्या होता था, फोटो करंट इधर क्रिएट होता था, राइट? इफ इट इज 100 watt bulb means I told you that 100 electron will be ejected, just for the assumption. Okay, maximum 50% will be reaching this point. Now if you increase the watt of the bulb 200 watt means 200 electrons will be start to eject, again 50% of electron will be reached. This is the first scenario what we discussed. Correct now? Now the scenario is that I'm going to introduce here one battery. ये क्या है? Battery. Just a minute. I will redraw this one. I won't take more than 5 minutes to explain this one. Okay. This is a battery. When I connected this one, no. Now previously this is an anode. No worries. Correct now? But during this time क्या होता है, more and more positive charges will be start to occupy on this anode. Correct now? If more number of positons are present here, same 100 watt bulb is there, 100 electrons are ejecting from the metal surface. Okay, now let me know, guys, let me know. Now it is become more positive one, more positively charged plate हो गया. Now is the amount of electrons which are coming here, no, near the positively plate, is it increases or remains same as the previous? Battery connect ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ 50% electron ಈ ಕಡೆ ಬರ್ತಾ ಇತ್ತು. Now I connected a battery. ಇವಾಗ ಇದು more positive ಆಗಿದೆ ಅನ್ನೋ. ಓಕೆನಾ? ಪಾಸಿಟಿವ್ನೆಸ್ ಜಾಸ್ತಿ ಆದ್ರೆ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ನ ಎಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತಾನೆ ಇರುತ್ತೆ ಜಾಸ್ತಿ. ನಾವು ಇವಾಗ ಹೇಳಿ ಪ್ರೀವಿಯಸ್ ಆಗಿ 50% ಇತ್ತು, ನಾವು the same 50% electron will come or more than 50% of electron will be come near the anode. This is my question. Yes, more than that. Shall we take around 70%? Due to collision also they will lose. No worries. 70% ಬರೋದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು. ಮೀನ್ಸ್ ಇಂಟೆನ್ಸಿಟಿನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಎಜೆಕ್ಷನ್ ಜಾಸ್ತಿ ಆಯ್ತು. ಇವಾಗ ಪೊಟೆನ್ಶಿಯಲ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು, again electrons rate coming near the positive end will be more. Means photo current which is producing in this kind also more. Correct na? More. क्या हो गया, photo current value also more. Clear? Okay. First scenario. Next क्या करता है मैंने, now I will do reverse connection. क्या है, रिवर्स कनेक्शन करना है. इस देखो अगेन सेम सर्क्यूट, क्या हो रहा है मेरे साथ भगवान. यस, नो देखो इधर. Now I connected this anode with a negatively charged plate. Okay ना. Now on this plate क्या हो गया, negative charges start to accumulate. Okay. Now negatively charges start to accumulate means this plate is negatively charged, electrons also negatively charged. When there is no battery, photocurrent value is there. Before the battery only photocurrent is present. Okay. When you supply some amount of potential at the time, photocurrent value क्या हो गया, increase हो गया with a positive potential, positive terminal connect करने से. Now I connected this one with a negative terminal. On this plate negative charges start to accumulate. Right now when it is become more negatively charged particle, electrons also negatively charged one, they are coming near the negatively charged particle, but our nature is not supposed to attract the negative and negative charges. क्या होता है, it will start to oppose the negatively charged electrons, push करता है opposite direction. Correct ना. One by one here 100 number of electrons will be moving, the 100 number of electrons ejected from the metal surface. Okay, around 50% will be coming near this surface, near the anode. Means due to this negatively charged particles present on anode, they all are trying to stop the electrons which are coming nearby the anode. And out of 50 here, 50% means 100 में 50 होता है ना. Out of 50, one electron will get the maximum amount of kinetic energy, right? I don't know which one. Okay, any one electron will get maximum amount of kinetic energy, that is moving very fastly, no? In a small unit of time में that electron also stop. Means it also won't move further distance. Correct now. At that particular time, right, potential क्या होता है ना, we call that one as an stopping potential. Okay, during this stopping potential the value of current will become zero. The value of current will become zero. Okay guys, this is all about the photoelectric effect. When we without giving up potential also we generated the electron, right? And during that time electron will be moving means current is generated, we call that one as an photocurrent. And when we connected with a positively potential, the photocurrent value increases just because of anode get positively charged more. Right now when the potential will be reversed, correct, anode is more negatively charged now. Due to the negatively charged anode, it opposes the electrons which are coming towards it. Okay, in a small unit of time it opposes all the electrons which are ejected from the metal surface, and it makes the current value completely zero. During that time whatever the potential will be developed in between these two, no, we call to make zero current, whatever the potential we supplied, no, we that potential we called as an stopping potential. Clear? We are going to write the graphs based on concept. Okay, the next class, guys. Okay, graphs. Definitely, I'm going to take you in the next class. I hope you understand. Okay. Meanwhile, if you have any doubt, means please drop your doubts in the chat box. This is all about today's class. This is all about today's class. Meanwhile, if you have any doubt, means please drop your doubt in the chat box. Okay, thank you. If you don't have any, if you don't have any doubt, means you can leave the class. You can unmute and you can talk also if you have any doubt, means I will allow you all. Okay, it's a good to go. Guys, take care. Bye bye. We'll meet in the next class.